Hi, today we're going to learn about rational functions, and in this section I will graph rational functions with holes in the graph, top heavy or oblique asymptote, bottom heavy, and when the degree is the same. So let's start with the first problem. So it says, sketch the graph of each rational function. Find the domain first. So first what I'm going to do is, so we have the function f of x equals x squared minus 1 divided by x minus 1. And then the first step I'm going to do is simplify the numerator. This x squared minus 1 is simplified as, since that's a perfect square, I'm going to say that's x plus 1, x minus 1, divided by x minus 1. Let's look, so on the numerator we have an x minus 1 and x minus 1. So whenever you're in this situation where the when something cancels, like these two will cancel, whenever you're in a situation like that, that means there's a hole in the graph. And if you were to look at the top degree is 2, and then bottom degree is there's an invisible 1. So that means it's top heavy. And we have an oblique asymptote. Oblique asymptote. So when you have an oblique asymptote, that means your horizontal asymptote is going to be linear, and then to do that you have to do long division. So first let's find our vertical asymptote. Usually when you find your vertical asymptote you set the denominator to 0, but since these cancels, we can't set it to 0 because it cancels, so we have none. For this case, we have none for our vertical asymptote. And what about our horizontal asymptote? Remember, when it's top heavy, so 2 and a 1, you're going to have to use long division. So I'll put it right here. So we're going to have x squared minus 1 divided by x minus 1. So this is going to be an x, right? That's x squared minus x. Put the parentheses, distribute the negative, so that cancels. Two negatives becomes positive, so this is going to be x, and then don't forget this negative 1, so it's going to be x minus 1. And then I'm going to say plus 1, because 1 times x is x, and then 1 times negative 1 is negative 1. Distribute that negative, so the x cancels, and then the 1's cancel as well, so you're just left with x plus 1. So our horizontal asymptote is y equals x plus 1, and it's definitely linear. Good. Now remember how now let's look at the hole in the graph. Where we got to find the coordinate where the hole in the graph is. So the hole is going to be at the x value is going to be 1, and how I got that value, x equals 1, right? I said since the x minus 1 cancels, so the x minus 1 cancels, I'm just going to set that to 0 because add 1, so that's how I got x equals 1. Now let's find the y value for the hole. So all you got to do is plug in 1 into the function. So let's say the function is, it's just going to be, the x minus 1 cancels, so it's just going to be x plus 1, right? Now we have to plug in 1 into the function, so it's going to be f of 1, because that's our x value. So that's 1 plus 1, which is 2. So our y value at the hole is going to be 2. So it'll be a hole at 1, 2 if you want it in coordinate form. So we're going to need that, and then I guess we could start graphing. So let me put it right here. Okay, so let's first, we don't have a vertical asymptote, so it's none. And then our horizontal asymptote is y equals x plus 1, right? Remember, there's two ways you can graph it. You could start as 1 and then go up 1, right 1, up 1, right 1. Or you can just find the x and y-intercept. So we know our y-intercept is 0, 1, right? So y-intercept is 0, 1. So it's right here. And then our x-intercept is when you set 0 to y, so it's going to be 0 equals x plus 1. So I'm going to subtract 1, so our x-intercept is negative 1, 0. Yes, negative 1, 0, so it's going to be right here. And then usually it's for horizontal, it's going to be dashed. Dashed, but this case, since we have a hole in the graph and it's top heavy, and we don't have a vertical, it's going to be solid. The line is going to be solid, not dashed. It's usually dashed, but we don't have, there are things that we don't have a vertical asymptote, that's why. Whoops, hold on. Before I make the solid line, what I'm going to do is I will make the hole first. So the hole is 1, 2. So it's going to be open circle because there's a hole in the graph. This is 1, 2. And then now I can make a solid line. And I'm not going to go through the hole, so it's going to be... So it looks something like this. You can make it more prettier if you want. But it doesn't pass through that hole, so it's going to skip and then just keep going linear. The problem doesn't ask you, oh yes, we have to find the domain first. So I did it last because I have to see how the graph looks like to figure out my domain. So our domain, let me put it right here. It looks like it's, since it's linear, it's all real numbers, but it doesn't pass through the hole. So remember, x is this is our x value and this is our y. So the domain is going to be all real numbers except when x equals 1, because that's our hole. It doesn't go through that point. And then our range, since it's still linear, it's going to be all real numbers except when it hits the hole at the y value of 2. So all real numbers except when y equals 2. And it didn't say find the range, but I just made it anyway. So yeah, that's how you graph a hole in the graph, and when it's top heavy and you're going to have a oblique asymptote. So let's do another one. Let's try this one. So it says sketch the graph of each rational function. Find the domain first. So we have x plus 1, f of x equals x plus 1 over x squared minus 1. First step I'm going to do is I'm going to simplify. The numerator stays the same because it can't be simplified anymore, so it's going to be x plus 1. And then our denominator, this simplifies. This is the perfect square, right? So this is going to be x plus 1 and x minus 1, right? So let's look here. Remember how if something cancels, like this x plus 1 and x plus 1, if they cancel, that means you have a hole in the graph. You're going to have a hole in graph. Now let's look at the degree. Okay, so let's look at this part. We have an we have a 1 here, and then we have a 2 here. So that means it's bottom heavy, right? Because the bottom is heavier than 1, right? 2 is bigger than 1. So that means our horizontal asymptote is going to be y equals 0. So okay, first let's find the whole, if that makes sense. So where the x plus 1 and the x plus, where the two numbers cancel, I'm going to set that to 0. So in this case it's going to be x plus 1. Set that to 0, and then solve for x, so that's going to be minus 1, minus 1. So x equals 1. So whole is at x equals 1. Right? Yes. No, it's negative 1, sorry. X equals negative 1. X equals negative 1. So that's our x value. Now let's find the y value. So our new function is going to be, since this cancels, it's going to be just 1 over x minus 1. And if you were to put negative 1 into the x value, so it's going to, what if f of negative 1 is going to be 1 over negative 1 minus 1, which is 1 divided by negative 2. So our whole is going to be at x value at negative 1 and y value negative 1/2, or negative 0.5. It's the same thing. And then, okay, so let's find our vertical asymptote. So our VA is always, you set the denominator to 0. So since these cancels, you're just left with x minus 1. And you set that to 0. So I'm going to add 1, add 1. So our vertical asymptote is just x equals 1, right? Our vertical, that's our VA. Our horizontal, since it is bottom heavy, whenever you have a bottom heavy, the y, you're going to have a horizontal asymptote of just y equals 0. Okay, is that all we need to know? And yes, now we can start graphing. So we have our VA, horizontal, and our whole graph, our whole point. Sorry, that was not really nice. This is your x and this is your y. So this is going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, so we said our VA is x equals 1. So here's x, and it's going to be the dashed line because it's an asymptote. And then our horizontal is right here, which you just have to remember, or is 0. So you could put a dash if it makes you feel better. Just make sure you don't go over the y equals 0. Okay, so now let's find out where our hole is. So our hole is negative 1 to negative 1/2, because so here's negative 1, negative 1/2 is right here. So that is our hole. So this is going to be negative 1, comma, negative 1/2. Now, okay, so we have our hole. Now we got to figure out which side is on our vertical asymptote. Is it going to go this way, or is it going to go this way? We don't know. So this is where we have to test points. So I got to figure out, so I can't use the x value of 1 because that's our vertical asymptote. So I'm going to use the x value of 2. So I'm going to do f of 2 which is 1. Okay, 1. So our function is 1 over x minus 2. So 1 f of 2 would be 2 minus 1. So that's 1 over 2 minus 1 is 1, right? So that point is going to be 2 comma 1. So here's 1, 2, and 1. 2 comma 1. Okay, so I'm still iffy about how is it going to look like. I assume it's going to look like it's going to go like this, but I will, because I'm not 100% sure, I'm going to just test another point. So I'm going to do f of 3. So f of 3 equals 1, 3 minus 1. So that's 1 over 3 minus 1 is 2, so that's 3 comma 1 half. So here's 1, 2, 3, comma, and then half is right here. So I know it's definitely going to go like this. It never passes the 0 because that's our horizontal. It gets really close, but it never touches. The same thing with the x when it's 1, so it gets really close to 1, but it never touches it. Okay, so this is what the left side looks like. Now let's look, the right side. Let's figure out what the left side looks like. So, I don't know. I'm just going to guess points, so I'm going to try. I will not use, what point? I will try 0.5. So here's 0.5. If I choose 0.5, f of 0.5, I'm going to get 1 over negative 0.5, which is about negative 2, if you put it in the calculator. So that point is going to be 0.5, comma, negative 2. So here's 0.5, negative 2. It's going to be right about here. Okay, I still don't know how it's going to look like. I assume it'll go like this because that's our horizontal asymptote. So I assume, but I'm not 100% sure, so I'll just put another point. I'm going to try negative 2. So if you put negative 2 in the function, you get 1 divided by negative 3, which is about, I don't know, negative 0.37. Negative 0.37, so that's going to be, that point is going to be negative 2, comma, negative 0.37. So here's negative 2, and then negative 0.37 is about, here's 0.5, it's going to be right here. So I was right. It will look something like this. Doesn't go through the hole, right? It doesn't go through the hole, and then goes like this. That is how your graph looks like. See how it doesn't pass through the 0, but it gets really close, right? It eventually keeps going up, but it'll get really close to 0, but it never touches. So what do you think our domain is going to be? Our domain is going to be all real numbers except all real numbers except when x, it's going to be our vertical asymptote when x equals 1, so it can never be 1. It can never be 1, right? And what else? It can't go through our whole graph, right? So and our x value is -1, so it could be 1, and then x cannot be -1. Right? That's because that's our whole of our x value. What do you think our range is going to be? It will be, since our horizontal asymptote is 0, so it's going to be from -infinity to let's see. Remember our whole graph. We have to keep in mind of our whole. So our y value for -1, our y value for our whole is going to be -1, right? So it's going to be from -1 union -1/2, -1/2. I mean, yeah, -1/2, and then it'll get really close to 0 because that is our horizontal. So it's going to be 0 union 0 to positive infinity. And so that's how you so that's how you sketch. This one is a hole in the graph, and it is bottom heavy. So that's how you graph a hole in the graph and a bottom heavy rational function. Another one. So let's do f of x equals 2x squared minus x over x minus 1. So let's look at the degree. Can it be simplified? 2x squared minus x? I don't think so. You could factor the x, right? That'd be... No, I wouldn't factor that x. I'll just leave it the way it is. And then what I'm going to do is let's look at the degree. This is 2, and the highest degree on the bottom is 1. So that means it's top heavy. So that means you're going to use oblique asymptote. You're going to have an oblique asymptote. And then, so it's going to be linear. So it's going to be linear. And you're going to have to use long division. So let's find our VA first. Our VA is when you set the denominator to 0, so it's going to be x minus 1 equals 0, so you're going to add 1 to both sides. So our VA is x equals 1. Let's find our HA. Since it's top heavy, we're going to have to use long division. So it's going to be 2x squared minus x divided by x minus 1. I'm going to use 2x, yes, 2x. So 2x times x is 2x squared, times 2 minus -1 is -2x, distribute the negative, that cancels, because 2x squared minus negative 2x is cancelled, and then 2 negatives becomes a positive, so it's 2x minus x, which is just x. And then let's keep on going, so I'm going to say plus 1. 1 times x is x. 1 times negative 1 is negative 1. Distribute the negative, the x cancels, and then you get positive 1. So the remainder is going to be 1 over x minus 1. But we don't really care about this part. We only care about the linear function, this part, 2x plus 1. So that is our horizontal asymptote. So our horizontal asymptote is y equals 2x plus 1. Good. So now we can graph it. Okay, so we know our vertical asymptote is at x equals 1, so it's right here. It's going to be dashed. And then our horizontal asymptote is 2x plus 1. I could start at 1 and then go up 2, rise 1, up 2, rise 1, but I'm kind of lazy, but I just want, so I'm going to find the y-intercept and the x-intercept. So our y-intercept is 0, 1, right, because it's right here. And then our x-intercept is, you set 0 for y, so it's going to be 0 equals 2x plus 1 minus 1 minus 1. So it's negative 1 equals 2x divided by 2 divided by 2. So x-intercept is going to be negative 1/2, comma 0. So here's 0, 1. And then negative 1/2 is right here. And it's going to be dashed. For this, remember the last problem I said it wasn't dashed because it was because we didn't have a vertical asymptote, but this part we do, so this is going to be dashed. So it's going to look something like this. If you can make your graph look nicer than mine's, that's good. Okay, so I don't know. If you want, you can label it. So this is x equals 1, and then this is y equals 2x plus 1. So I got to figure out which way is it going to go. Is it going to graph? I don't know which way on the right. So we have a right side, and we have this side. I don't know. Is it going to go look like this, or is it going to go like this? I'm not sure. So I'm going to test points. So I can't. First point, I can't use 1 because that's our vertical asymptote. So I'm going to use an 2 of x value of 2. So I'm going to use f of 2. So here's our function. So you plug in 2 into the function. That's going to be 2 times 2 squared minus 2 over 2 minus 1. And that will give you 6 over 1. So that point is going to be 2, 6. So here's 1, 2, 6. 1, 2, 3, 4, 5, 6. Oh, 1, 2, 2, 3, 4, 5, 6. So it's going to look something like right here. It's inside this. So that's enough to know that it's going to look something like this. It's going to make this U shape. Whoops, it doesn't pass through this point, right? So it's going to look something like this. So we know this part. Now let's go on the bottom. The first point I'm going to use is 0, f of 0. Right, I can use f of 0 because it's not our VA and it's not going through any of our X or Y-intercept. Right, yeah. Yeah, because it's -1, yeah, so I could use 0. If you plug in 0, you get 0. So that point is 0, 0. So here's 0, 0. That still doesn't tell me enough, so I'm going to use another point. I'm going to use 1/2, positive 1/2. If you plug in 1/2 into the function, you should get 0. So this point is 1/2, 0. So here's 1/2 right here. So it should look something like this. Is enough to tell me it's going to make that U shape. It won't pass here, right? Because I said 0. So it's going to go like, oops, like this. No, it doesn't pass the horizontal asymptote. And yeah, that's it for this part, and it doesn't ask for domain. Yeah, it doesn't ask for a domain. So this is an oblique asymptote, and when it's oblique, that means it's top heavy. 2 more, and then we'll be done. Let's do this one. We have f of x equals 4x over x squared minus 2x plus 1. So it says find all, this one they're going to ask me find all asymptotes, X-intercept, Y-intercept for the graph of each rational function and sketch the graph of the function. So first step is I'm going to simplify. Can we simplify the numerator? Nope, it just stays as 4x. Second, we can simplify this, right? This is factored as x and x minus 1 minus 1. Right? Because -1 times -1 is +1, and when you add those two, you get -2. Okay, so nothing cancels, right? Yeah, nothing cancels, but it's still nice to make sure it can be simplified to this. So we know this is bottom heavy, right? Because we have a 1 degree here and we have a 2 degree here. So it's bottom heavy. So bottom heavy. So whenever you're in it bottom heavy, your horizontal asymptote is going to be just 0. That is just part of the rule for bottom heavy rational functions. So let's find our VA. So you get our VA is going to be just x equals 1, right? Because if you set these to 0, x minus 1 and x minus 1, you're still just going to get 1. right? X minus 1 equals 0, X minus 1 equals 0. You're just going to get 1. And then our HA is Y equals 0 because it is bottoms heavy, and whenever you have a bottom heavy, your HA is just 0. Y equals 0. There's a difference between 0 and none, right? In this case we have a HA, it's just 0. So I think we have enough information to graph it. We do. Okay, so we said our vertical asymptote is x equals 1, so here's 1. You can label this as x equals 1. And then our horizontal is y equals 0, so you don't have to make the dashed line, but just remember it doesn't go past through the 0, or the y equals 0. Now I gotta figure out, here I'll just put a dash just in case, of 0. So I gotta figure out how is it gonna look on the right side and how is it gonna look on the left side. Could it look like this on the right side, or could it look like this on the left side? I don't know, so the best way to figure out is test points. So the first point I'm going to use of our x value is I'm not going to use 1 because that's our VA, so I'm going to use 2. So f of 2, and if you put 2 into this function, right, you're going to get 8. If you don't, I just did the work, so if you don't know, you could just put the work, so wherever there's an x you plug in 2, and then you'll eventually get 8. So you're going to get, so your coordinate is going to be 2, 8. So here's 2 and here's 8. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So here's 2, 8. Right about here. I think it's going to look, it'll look like this, go down, but I'm not sure, so I'm going to use another point. I'm going to do f of 3. I'm going to use 3, and if you put that into the function, you should get 3. So your coordinate is going to be 3, 3. So here's 1, 2, 3, 1, 2, 3. I'm still iffy. I'm not 100% sure, so I know it's gonna look, yeah, now I know it's gonna look something like this, but I want to be really detailed, so I'm gonna use another point, f of 4. If you plug in 4 into the function, you should get 16 ninths, and that's about 1.7. So our point is going to be 4, 1.7. So here's 4. 1.7 is about here. So yeah, now it's going to look something like, and it gets really close to 0 because that's our horizontal. Oops. And it gets really close to 1. Okay, now we know what the right side looks like. Let's figure out what the left side looks like. Okay, so on the left side, I'm going to use 0. I'm going to use 0. So I'm going to start here. So f of 0. If you put that into the function, you're going to get 0. So that's 0, 0. Good. So it's we don't have an Y-intercept or an X-intercept. We just have it passes through the point 0, 0, right? So it passes through the origin of 0, 0. Okay, let's try -1. Put that into the function, you should get -1. So you're going to get -1, -1. Here's -1, -1. Let's try another one. That's still not enough to tell me how it's going to look like. So I'm going to do f of -2. If you plug in -2, you should get -8/9, which is about -0.8. So here's it's going to be, so our point is -2, -0.8. Here's -2, 0.8 is about right here. And that point should be right here. Still not enough. I'll try -3. If you plug in -3, you get -12 over 16th, which is about -0.75. So that point is -3, -0.75. -3 is -0.5, should be right here. Okay, so we said that our horizontal is 0, so it's going to get really close to 0, right? Oops. It goes through these points, and then it goes up right here, and then gets really close to our vertical asymptote, but never touches. And that's how it should look like. It's kind of strange, right? So that's why sometimes it's good to put points if you're not 100% sure how it looks like. And we don't have our intercept is just it passes through the origin of 0, 0. That's it. Okay, last one. F of x equals x over x squared minus 1. First step, what I'm going to do is I'm going to see if it can be simplified. So this top stays the same. This is a perfect square, so it's going to be x plus 1, x minus 1. Okay, so since nothing cancels, there's no hole in the graph. So, okay, since there's no hole, let's look at the degree. So we have a 1 here, and we have a 2 here. So it's definitely bottom heavy. So you know what that means. It means that our horizontal asymptote is going to be 0. So let's find our vertical asymptote. Our VA is going to be, so if you set the denominator to 0, right? So x plus 1, x minus 1 equals 0. You're going to get two x values. So you're going to get x equals 1 and x equals -1. And then our HA is going to be y equals 0 because it's bottom heavy. Now we can graph it. We have enough information to graph it. It's going to be our x and this is going to be our y. Okay, so let's set our VA is 1 and -1. This should be a -1. So here's 1, and it's going to be dashed. And here's -1, so this is x equals 1. -1's right here. This is x is -1. Now our horizontals here, just make sure it doesn't go over the 0. So now we have 3 sections. We have the right side, we have a middle side, and we have a left side. So we got to figure out how is it going to look on the right, middle, and left. So we figure out how to do that. We're going to test points. So first point I'm going to do is 2, because 1 is our VA, so f of 2. If you put 2 in the function, you should get 2/3, which is about 0.6. So that point is going to be 2, 0.6. Here's 2, and 0.6 is about here. Let's try another point, f of 3. F of 3 is, you're going to get 3/8, and that's about 0.375. So that point is going to be 3, 0.375. Here's 1, 2, 3, 0. It's going to be right here. So it's going to go down. It'll get close to 0, but it never touches. Good. Now let's try the middle. First point I'm going to do simple is just 0. If you plug in 0 into the function, you should get 0. So here's 0, 0. So just like the same last problem, it passes through the origin. Let's try 1/2, positive 1/2. So right here, here's 1/2. So that would give us, if you do all the work, you should get negative 0.6. So our point is going to be 1/2, negative 0.6. Here's 1/2, negative 0.6 is about here. Okay, now let's try -2. Wait. No, let's try -1/2. So right here, that should give you negative. That should give you positive 0.6. So it's going to be -1/2, 0.6. So here's negative 1/2. 0.6 should be right here. Oh, here's negative 1/2. And then you go positive 0.6. So it should be right here. So it's going to look something like this. It's going to look good. And it never passes through these asymptotes. It'll never go through x equals 1 or negative 1. Now let's figure out what it's going to look like on the left side. So the left side, I will just use, negative 2. If you look at negative 2, you get negative 2/3, which is negative 0.66. So that point is going to be negative 2, comma, negative 0.66. So here's negative 2, negative 0.66 is about right here. And that's enough to tell me it's going to go like this, because we know it'll never pass through, goes through 0, because that's our HA. So that's enough points. That's enough testing points for the left side. So on the left side, it's going to look like this. On the middle, it's going to have this weird shape. And then on the right side, it's going to look something like this. The problem doesn't ask you the domain and range, but I'll just tell you anyway. So the domain is going to be from negative infinity to negative 1, because that's one of our asymptotes. And the reason why I'm going to use parentheses, not brackets, because since this is an asymptote, it gets really close, but it never touches. So that's why it's a parentheses. I'm going to use union from negative 1 to positive 1, because that's our other asymptote, 1. And then from union, I'll put it here, union, it would be 1 from positive infinity. And then our range, I'll put it right here, is from negative infinity to 0, because that's our HA, union 0, comma, positive infinity. And the only intercept we have is that it passes through the origin. Passes through origin of 0, comma, 0. So that's how you graph this part, this bottom heavy. Let me go back to the last problem. I didn't do the domain. This was, but yeah, let me just do the domain really quick. So the domain for this problem is going to be from negative infinity to 1, because that's our VA, one of our VA, that's our only VA, union 1 to positive infinity. And then our range is from negative infinity to 0, because that's our HA, our HA asymptote is 0, so it's going to be parentheses, because it gets really close to 0 but it never touches it. Union 0 to positive infinity. And yeah, that's how you graph these rational functions. So when I went over hole in the graph, and then I went over top heavy or oblique asymptote, and then I went over bottom heavy, and then I went over when the degrees are the same. So that's, and then also I did another video on just other more rational function problems. So if you look over this and then over my last rational function videos, you should be a pro at graphing rational functions. So that wraps it up for this section.